So it is kind of cold in here, so we're going to do a warm up though. It's like freezing in my classroom. So little warm up. We're solving linear equations in standard form. I want to see if you guys can do 1, 2, 3, and 4. And I will zoom in on those so you can see them nice and big. Subtract 5. All right, subtract 5. We got x equals -5. Put a thumb up. You got that one right? Woo! Easy. Yes. Next one, number 2. I got 14x equals 20. What was the first thing you did? And I don't want to hear the same people over and over. What did you do, y'all? Again, great review from 2-1 and 2-2.
Divided by 14 on both sides.
Attaboy. Nice job, Greg. You can go ahead and reduce 20 over 14 by what, 2? So 10/7. If it says give it as a fraction, that's what you do. And if it said give it to us as a decimal, then just use your calculator, figure out what 20 divided by 14 is, or 10 divided by 7. And that's about 1.4285-ish. 10/7 is perfect. Nice job. All right, now it gets a little tougher. It gets a little tougher. Here I have 5 plus 3x equals 10. What's the first thing you guys should do? What's the first thing we do over here?
Subtract 5 from each side.
All right. Okay. Now make sure you're not adding 5, because 5 plus 5 would be 10. It doesn't cancel. This guy wants to cancel. That leaves me with 3x equals 10 minus 5 is 5. And then my last step is like example 2, we divide by 3. And I got 5/3, or what? What is that? 1.6 repeating. Okay. So not too bad. Awesome. So again, we're isolating that x. We're getting that x all by itself. Like x has, dare I say, COVID. We're trying to get everything away from it, right? Put them in quarantine. All right, last one. I got 2x plus 7 equals x minus 5. What'd you guys do first? What did you all do first?
My first steps was there. I got x. I took x minus 2, or well, 2x minus x, which would give me x plus 7 equals -5. And then after that, you do minus 7, which would get you. Would that get you -3?
So 5 and 7 at -5, -7. If you owe me $5 and you borrow $7, now you owe me $12.
Or 12.
Nope. So you can see that there. Okay. So Lily said subtract the x over. We want to get the x's on the same side. So 2x minus x is x, plus 7 equals -5, and then we subtract the 7 over. If you owe me $5 and you borrow 7, now you owe me even more dollars. Now you owe me 12. 5 and 7 is 12, so -12. Okay. All right, fantastic. Yeah. You guys are doing great. Okay. I'm going to skip over these. I'm going to jump right to number 8 then. So we just skipped 3 questions, guys. You guys are doing awesome. Okay. Number 8, I have x plus 6 equals 2 times the quantity x minus 3. So this takes us back to chapter 2:1. What do we do over here, y'all? What's that property called? Yeah, good job, Jake. Or is that sorry, that's Madeline. If you're walking around, just don't go to the bathroom, okay? Like on that one video. All right, so 2 times x is 2x. 2 times -3 is -6. Okay? So this is where we want to get those x's back on the same side. You can subtract the 2x over, or you can subtract the x over, kind of whatever you want to do. I'm going to do this. So I get x minus 6 here and equals 6. And then some of you guys are kind of, you go too quick and you'll say, oh, the answer is 0. But if you show your work, it only takes a second. Sorry, they're mowing outside. We get 12 equals x. Okay? Now, if this was a quiz or test, I'm like, I just don't like that. I don't like how that looks. It looks backwards to me. Anytime we're solving for a variable, we want x equals, right? Not 12 equals x, it's x equals 12. So this is backwards. If this was a quiz or test, I would not take points off. I would just write this on your paper. And you know what that says? Y-O-D-A. You guys know Master Yoda, right? From Star Wars, the little green guy, big ears, like Mr. Gotch, big ears. Yeah? He talks backwards, doesn't he? He goes, hard to see the dark side is. Yeah? He sounds kind of backwards when he says stuff. That was a good impression, wasn't it? Yoda? Anyway, so that needs to be rewritten. Okay, now when you're typing in my math lab, they probably already have x equals, and then you just plug it into 12. But that's it. Okay? You guys have any questions with number 8? So you could see some distributor property now mixed into some of the problems. I do want to go back and talk about 7, because I can see there's going to be something that happens here. Okay, so I have 2, so this is what I got, 2 minus 7x equals 2 minus 7x. So the first thing we want to do is get the x's on the same side. Do you see what's going to happen? When I add the 7x over, they cancel here and I get 2, and they cancel here and I get 2. Well, there's no more x's to solve for, right? All of the x's have disappeared. Okay? You guys probably never seen the Bozo show in Wizzo. Wizzo used to go doo-doo-doo-doo-doo. He used to be a little clown that was a wizard. Wizzo the wizard. Anyways, all of them disappeared. Now, ask yourself, is 2 equal 2? Is that true or false? Is 2 equal to 2? And you guys agree 2 things equals 2 things. I'm seeing thumbs up. Yeah, 2 equals 2. So if it's true, then we get what's called infinite many solutions, IMS for short, or the infinity sign, okay? Or all real solutions, okay? If you ever solve and you get like 3 equals 0, or you get negative 2 equals 5, or something like that, that doesn't make sense, does it? Negative 2 is not equal to 5, 3 is not equal to 0. So if you get something that's false and you're going through, then that's the empty set, that's the null set, that's no solution. Okay, so just be aware of that. If you're trying to solve for x and they ever cancel out, that just means that's not possible. You can't do that. If you get a false statement. If you're solving and they are true statement, then anything works for x. Any number you could think of. So that's all real numbers, infinite many solutions, or the infinity sign. Okay, do you guys have any questions with those? All right, let's get to some tougher ones. What do you say? Let's get to some tougher ones. Number 12. OMG. Oh my gosh. So in this section, the OMG scale, the oh my gosh scale, I would probably put this at like a 7 or 8. This is going to be as hard as it's going to get for you guys. Okay. This is 5x minus 2 times this quantity of 4x plus 3 times the quantity x minus 1 equals 8 minus 3x. You're like, holy cow. Now, this is the perfect time to talk about our Dear Aunt Sally rules. You guys remember our Dear Aunt Sally? Please excuse my dear Aunt Sally. Okay? What do we do first? How do we start simplifying all this mess? Yeah, so they have two different parentheses. They have brackets that are really like parentheses, and then they have parentheses in there. So you work on the inside. So you're going to take care of this guy right here. So exactly what Cole said. Let's go ahead and take care of that first. Okay? So I'm going to rewrite it. I have 5x minus 2 times this bracket of 4x. And now I'm going to distribute 3 times x is 3x, and 3 times negative 1 is negative 3. Okay, so in red is what I've done so far. So far, so good? So now I'm going to go even further. Cole, what are you going to say? Awesome. So we can combine this little mess here, right? We can work inside those parentheses or in those brackets. So I'm going to highlight what I'm doing so you can kind of follow along. So now I've got 5x minus 2 times that bracket. 4x and 3x is 7x and then negative 3. Those are unlike terms. So fantastic. Good job, Cole. Well, we still have parentheses or these brackets we want to get rid of, right? So now I'm going to distribute this negative 2. Make sure you take the sign, the negative sign, along for the ride here. Okay, so now I have 5x. Negative 2 times 7x is negative 14x. What's negative 2 times negative 3, y'all? Negative 2 times negative 3 is? Positive 6. I think you said that, Cole. You're just kind of, it's hard to hear. You're like in slow motion. All right, so we distributed, we get plus 6. Okay. Well, now we want to kind of combine or like terms. Let's clean up this side a little bit. Okay, so adding, subtracting these guys, 5x minus 14x, when they're on the same side, we combine them. 5x minus 14x is how much? Negative 9x. And now let's get the x's on the same side. I like working with positive x's, so I'm going to add the 9x over. So I get 6 equals 8. Negative 9 plus, or negative 3 plus 9 is what, 6x? Now we can subtract the 8. 6 minus 8 is negative 2 equals 6x. Sorry, I'm running out of room if you're printing these out. I'm going to have to change that for next year. Reduce. And they reduce by what, 2? So negative 1/3. Holy moly. But if you look at it, it's not so bad. And it's good review of what we did in chapter 1. A little, please excuse my dear Aunt Sally. Okay. Do you guys have any questions with that one? So that's not too bad. All right, let's do the next one. No questions on that one. You guys are okay. Give me a thumb. Where are we at in this stuff, guys? Give me some thumbs. Are we here? We're okay. Thumb here. Mostly up. Okay. All right. On this one, I would say this is about, again, we said like a 7, right? Here's one last one I want to show you. Okay. And I have an extra one we can do with these. Okay. So this is a division sign. And let me rewrite this so it's nice and big. I have 3x over 2 minus 1/3, and that equals 2. So I wrote that nice and big for you guys. All right. Now, we can leave these as fractions if you want, or I can show you that trick to get rid of fractions again. Do you want to see that trick? Yeah? People are like, yeah, I don't like, who likes fractions? Raise your hand. Mrs. Williams, she does. Mr. Gotch does, and I think that's it. There's nobody else that likes fractions. So let's get rid of these fractions. Let's get rid of this denominator here and this guy here. Okay? Well, to do that, we need that common denominator. We call that the least common denominator, the LCD. What's the common multiple or the common denominator between 2 and 3? It's got to be at least the biggest one or a multiple of that. What's the LCD between 2 and 3?
6.
Greg says 6. Perfect. When in doubt, you can always just multiply those two denominators together, and that's going to be your common denominator. It might not be your least common denominator, but at least you're going to get rid of those fractions. Okay? So, trick, we are going to multiply by the LCD. We're going to take 6 times every single term. So we're going to multiply by 6 to every single. I have 1, 2, 3 terms. Then I'm going to do. I'm going to do that math magic, and anything highlighted is going to disappear. So 6 and 2 reduce. 6 divided by 2 is 3. And now 3 times 3x is 9x. Okay? Any questions on what I just did there? All right, let's take this one. What's 6 divided by 3, y'all? 2. So that turns into a 2. And now I'm going to take this 2 times -1. So -1 times 2 is -2. And the last but not least, 6 times 2 is 12. So we took something that looks super duper scary. We multiplied all of it by the LCD. Okay? And then it gives me a nice, pretty equation. All right? All right, Jake, I got 9x minus 2 equals 12. What do I do from here, bud? How do I get this x by itself?
I don't know.
How do we isolate that guy? How do I move this 2, Jake, over there?
Add 2.
That a boy. Fantastic. So now, these guys cancel. So now I have 9x equals 14. Well, that x is almost by itself. I just got to get rid of that 9. How do I get rid of the 9 now? What can we do?
Subtract 9.
Close. This is 9 times x, right?
I did.
Yeah, the opposite of multiplication is division. Very good. So we divide by 9. And we get 14 over 9. So you're always trying to undo what is going on in this problem. So if it's minus 2, we add the 2 over. If it's 9 times x, then we divide it over. Okay, because 9 divided by 9 cancels. Negative 2 plus 2 cancels. We're trying to cancel them out. To cancel out addition is subtraction, and vice versa. To cancel out multiplication is division. Okay? All right, I want to give you guys one more fraction one. So I'm going to rewrite example 14 on my notes here. I got x over 5 plus 3x over 4 equals 19. Okay, so I've rewritten that one so it's nice and pretty big for you. So I'll give you guys a second, try this one out on your own. My hint to you is let's get rid of these fractions. Get rid of the 5 and the 4. What's the LCD? All right. Well, let's get started. What's the LCD between 5 and 4? What's going to cross out a 5 and a 4, y'all? 20. So I'm going to multiply all of these guys by 20. Anything that's highlighted is going to disappear. 20 divided by 5 is 4. And then multiply. 4 times x is 4x. Any questions of what I just did? Do it again. 20 divided by 4 is 5. 5 multiplied to 3x is 15x. And then what'd you guys get for 19 times 20? What's 19 times 2 and then add a 0?
380.
Boom. So we took something super duper scary. Oh my gosh, I was shaking in my boots. Shaking in my Jordans. Oh my gosh. Now look how nice and pretty that is. Any questions on how we got to this step? Are we okay with that? All right, when they're on the same side, we combine. If you have 4 x's and now you add 15 x's, now we have 19 x's. This is where we divide. This is 19 times x. The opposite of times is division. 380 divided by 19, we should get 20. Okay. Raise your hand if you got that one right. Put your hand on your head if you got that one right. We got it right. Does this count as right? Is that right? Or is that just kidding? That's a sneeze. You do that in class though, people are like, oh my gosh, you have corona. All right, nice work. Any questions on chapter 2-3, y'all? Are you guys good with chapter 2-3?